Hello everyone, this is the video for lesson 3.8b, modeling with cubic functions. We will be using DESMOS very heavily in this lesson. So we're going to be finding models using technology instead of using a formula like you did in lesson 3.8a. You can see that we have three different types of scatter plots. The first one over here on the left, that is a linear model. You know this is a linear model because the dots seem to follow a straight line pattern, and in this case it's specifically going to be a positive pattern. The middle one is from chapter 2. That is a parabola or a quadratic model, and this happens a lot when you have data that is recording projectiles or anything that you kind of throw. But real world data, it could be something like profit. When you're trying to sell something, you have that ideal like price tag here, or you could be talking about the best miles per gallon that your car could possibly get. And then over here on the right, we have a cubic model, and you have lots and lots of little dots. It's not perfect, but you can very clearly see that it kind of has this curved pattern. Now, there's a big difference between a parabola, which is quadratic, and a cubic. So a cubic's almost like a roller coaster top pattern, but then a quadratic, it just has either like a max or a min. Cubics can have both. So today we get to use the new and improved DESMOS. We have the easiest method now, no more coding involved. All you have to do is input the table of values. You're going to click this little plus sign in the upper left-hand corner of DESMOS. And then after you input that data, you can see your data. And you're going to do that by clicking on the little magnifying glass. So after you kind of see your data, then what you're going to do in the upper right-hand or upper left-hand corner, you're going to click on this regression button. So let me show you what it looks like in DESMOS. Okay, if you're not already on DESMOS, you need to kind of get there on DESMOS. I know it's a little bit weird. You're watching like the video and then you're also trying to work on DESMOS at the same time. So you might have to flip back and forth between the two. So just pause the video for a second and then go into a new tab and open DESMOS. Okay, so I am in DESMOS, and what we're going to do is we're going to click this little plus sign. And we want to go ahead and we want to type in all the data in this example over here on our notes right there. So just take a look at the worksheet that you have in front of you and input all of your X data and input all of your Y data. I'm going to pause the video and I'm going to type all this stuff in, and then we're going to start the video back when I have it done. Alrighty, I've got my data inputted into DESMOS, and I'm going to scroll down right here and I'm going to click on my Zoom Fit button. And you should see over here on the right hand side that this is definitely not a linear pattern. So linear would be a straight line, but I can very clearly see that there is a curved kind of pattern here. But what kind of curve is it going to be? Well, I can just use DESMOS over here to help me. This is the regression button. And what it does is it adds a line that kind of estimates the pattern over time. So I'm going to click it. It's going to automatically bring up a linear function. Now you can clearly see that this does not fit the data. So I'm going to scroll down a little bit, and then I'm going to choose a quadratic regression. So right now you're going to be choosing between these three. And remember, chapter 3 focuses on cubic regression. Let's see what happens when we click on quadratic regression. Well, it's definitely better than it was before, but it kind of looks like maybe this might curve down. So I'm going to check on the cubic regression. Now, look at how well that fits. It's important for you to know that a regression equation does not have to be perfect. There's no way that you're going to have a polynomial fit all of these green dots perfectly, but it's a lot closer than the quadratic one. So now you don't have to code anything. You just have to pick which regression you feel is the best one. So I think this is perfect. We're going to use the cubic model, but oh my goodness, look at these crazy numbers right here. So what we want to do in general, as a rule, we're going to round to whatever the degree of the term is. So this is a third degree term. See how it's got the little 3 up here for the exponent? We are going to round it to the first 3 decimal places. So it's either going to stay 583 or it's going to bump up to 584. That number next to it is a 3, so I'm going to keep that as 0.583, and then I'm going to ignore the rest of it and write x to the power of 3. So let's see what that looks like on our notes. Right there. And you're going to have to copy this down. So if they ask for a model to fit the data, if they ask for a linear regression, or sometimes they might say a line of best fit. All right, let's look at the second one. So since that has a degree of 2, I'm going to round that to 2 decimal places. So minus 2.08. And then this one's going to be 1 decimal place. Now this one's a little bit tricky, so watch out. It's going to be 7.9, but if you look at the next number, it's a 5. The 9 has to go up to 10, which pushes the 7.9 up to 8. So it's either going to stay 7.9, in which case, since at 5, it's going to bump it up to an 8. So it'll be 8x, and then minus 5. We're going to just do a whole number for our last term there. So this is what we're going to get for our whole polynomial function that fits the data. That's our model. And that's great and good if that's all they want you to do. But a lot of times they're going to want you to predict using that function. So underneath that, it says predict the value. It says when x is equal to 7. Well, we're in easy mode right now. So what you're going to do is you're just going to go to that second line and you're going to type in exactly what it says. X is equal to 7. So x is equal to 7, and what's going to happen is there's going to be a vertical line that pops up right here where x is 7, and we've done this before. Whenever they intersect should be the answer. So when x is equal to 7, that means your y value is going to be 148.3. I think in this case, I think we round it to the nearest whole number, and it's that simple. All right, so if you flip your notes on the back, I have a real world example and it's already worked out for you. I don't know why, but your textbook loves to split the table into 2 different parts. So when you type this into DESMOS, you're going to type in like 0, 2, 4, 6, 8, 10, 12, 14, 16, and then 20. And then these are all going to be your y values. Well, long story short, you don't actually have to type this one in. This is what it's going to look like when you zoom in to your data. And this is going to be the rounded model that you write down from DESMOS, okay? Then it says use the model to predict the number of nests in the year 2018. Well, if you look up here, the T stands for time. And you notice none of these are calendar years. There's no 2000, 2010, 2018. What you have to do is you have to understand that the T is the years after 2000. So 2000 is really convenient because you can kind of do that math in your head. Just be careful. Just make sure that you are reading the question before you type in your data, because sometimes it'll say like 2000, 2010, 2020. You just never know. Okay, this one starts at 2000. So 0 would be the year 2000. This would be 2002, 2004, so on and so forth. And then this last one would be 2020. All right, so what it's doing is it's asking you what would be the number of nests in the year 2018. So 2018 is 18 years after the year 2000. So you're just going to simply go to that second line and you type in x is equal to 18. And this vertical line is going to show up. You can't see it in the picture, but this would be the point where they intersect. So after 18 years, you're going to have about 1,561 eagle's nests. Okay, almost done. Let's take a look at the last example. So it says the data show that the annual commercial harvest in Y, that would be pounds of walleye, and if you don't know, it's a type of fish, looks like that, in a lake that's T years after the year 2000. So once again, we are starting with the year 2000. So if you look at this table here, T0 means the year 2000. So if I like go over here to the 8, that just means the year 2008. And then at the very end, it's 2020. So very similar to the Eagle's Nest problem that we just did. What I need you to do, I want you to practice this before you do any kind of like homework or daily work. So if you could just pause the video, type this in, and try to solve this problem with me, okay? All right, so I've got the data already typed in. You can see it's a lot of data, and I need to look at the data. I need to see what kind of shape that it makes. So that is a little bit crazy here. So I've got kind of definitely not a straight line. If it was a straight line, then it would be kind of not great. So let me click that, and it's going to automatically add a straight line. Yeah. See, I've got this, I don't know, it just has this curve pattern to it. The linear doesn't feel right. So let me change it to quadratic and see what it looks like. Okay, so that's actually worse. Let's try cubic. Okay, that's not too bad at all. Remember, real world data is not perfect. So that is definitely the best one out of the three, especially this point up here. It just kind of seems out of place unless you use a cubic regression. So what I want you to do is I want you to practice. This one's going to be 3 decimal places. So we're going to practice rounding it. So it'll be 0.270. And then you're going to write x to the third. Okay, this one's going to be 2 decimal places. Now that's got a 9 over here, which means that that's going to bump that up to 44 instead of 43. 1 decimal place on this one. Looks like we kind of have the same thing going on here. So instead of 82.9, that 6 is going to make it bump up to 83. And then a whole number here is going to be 111. So this is what it should look like on your paper. You can put y, you can put f of x. It doesn't matter which one that you use. And now that you've got that stored in your computer, what you can do is you can just do that second line method to help make predictions. So to make a prediction for the year 2018, once again, it is 18 years past that first year. So you're going to type in that second line, x is equal to 18. It'll let me get there. Okay, I made it work. So we're going to type in x is equal to 18, and it pops up right there. So 18 years after they started collecting the data, you're going to wind up with about 770 pounds of walleye. So let's go back over here. I didn't write it on my paper, but it's going to be 770 pounds of walleye. And that is it. That's all you got to do. All right, just let me know if you guys have any questions, and have a great rest of the day.